Fission technology is well known and understood, and we've been using it to generate power here on Earth for decades. But there's another kind of nuclear technology, and that's nuclear fusion.
Fusion is the power source of the sun. In the core of our sun, the temperatures are so high, atoms are moving so fast that they slam into each other, creating new elements and liberating energy.
The opposite of fission, fusion energy is produced when two atomic nuclei fuse together to form a single heavier nucleus. The result is a huge liberation of energy. A fusion-powered spacecraft was proposed in a 1970s study called Project Daedalus. Its mission called for a trip to Barnard's star, some 5.9 light-years distant. Instead of nuclear bombs, the fusion-powered craft creates the propulsion on board in a reaction chamber.
The fuel pellets for the Daedalus-class starship consisted of pellets composed of a deuterium helium-3 mix. These would have been ignited by what we call relativistic electron beams. These are extremely high-energy electrons that would have hit the deuterium helium-3 pellets, caused them to fuse, and a huge amount of energy would be released. The Daedalus design called for 250 of these pellets to be released every second for over 2 years. The spacecraft would have weighed 55,000 tons, most of which would have been fuel.
The weight penalty for such a spacecraft would be high, but an advanced civilization could eliminate the problem by mining the hydrogen fuel during its interstellar journey. Deuterium, or heavy hydrogen, exists in abundance on Earth, notably in seawater. But helium-3 is a much rarer isotope. In our solar system, it can be found on the Moon, and in vast quantities on Jupiter and Saturn. Scientists have proposed using huge hydrogen scoops to mine the helium-3 needed to cross the void of space.
So it's conceivable that if you had a craft that was powered by nuclear fusion, you could go to another star system and then use the hydrogen available from that star to refuel.
The self-contained, fusion-powered spacecraft could avoid a huge weight penalty and reach speeds that could allow near-star exploration in a reasonable time frame. The max speed of a nuclear-powered fusion spacecraft? Up to 15% the speed of light. Travel time from Earth to Alpha Centauri? About 35 years. The immense costs, the logistics, and even the politics of nuclear-powered spaceflight long ago caused humanity to scrap any and all plans. But a sufficiently advanced society could trade nuclear propulsion for what seems like an impossible paradox, traveling at light speed without moving at all.